Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. Today we are going to solve a problem on thermal stress. So this is the problem. So if you see the problem here, the temperature is varying with the length. The variation is given as delta T is equals to delta TB x cube by L cube. Okay. Suppose at both ends are fixed. Suppose at both ends are fixed. What this will mean? This means del net elongation of the bar should be 0 because the bar is fixed here and fixed here. Whatever fixed means they won't move anywhere. So whatever temperature you may change, but it won't move anywhere. So the change in length will be 0. Okay? Del net of the bar will be 0, and it is given E a coefficient of thermal expansion is alpha. So what is compressive stress developed in the bar? So if you see here, it is positive. Delta B is positive, X is positive, and L is positive. So change in temperature is positive, right? So it is varying along the X, but it is positive, right? Change in temperature is positive. This means if there is no constraint, then it will expand. But there is constraint, means but net elongation is 0 because of the constraint. If there is no constraint, if it is free from constraint, then it will expand. So the expansion is recovered. What I say, see the expansion, it is expanded by, suppose it is expanded by some length L, then it should be come back to its original place, right? That will be done by a reactive force P. So to come back, we need to have compression, right? To nullify expansion, we need to have compression. So compression means it will create a compressive stress in the bar. So the reactive force which is developed because of this constraint is compressive. So that is the reason why in the question compressive stress is asked. Okay, what is the compressive stress in the bar? So first we need to find out the elongation in the rod because of the change in temperature if it is free from supports. So if it is free and del L, then delta T will be is given by delta TB x cube. Is it x cube? Yes, x cube. Okay, this is now free end. Then how much it will expand? It will expand by del T. So del T may d, if you consider a small element of length dx at a distance x from here, then d del T will be given by alpha delta T, that is delta TB x cube divided by L cube into length is dx. Okay, then whole del T will be integration 0 to L is equals to del T, right? So del T will be 0 to L alpha delta TB x power 4 divided by 4L cube. So that will give us alpha delta B L power 4 by 4L cube. So del T will be equals to alpha delta B into TB into L divided by 4. So this is delta T, and we need to so we know that del net is 0, that is comprised of del T plus del reactive force, right? So we already, then it will give us del R, means deformation because of the reactive force will be is equals to minus del T. So because of a reactive force, suppose a reactive force, it is closed, right? Temperature is increased, because of that a reactive force R will develop. Let us assume it is positive. Then this is of length L, E comma A. Then del R will be given by R L divided by A E, right? We already know del T is given by alpha delta TB L divided by 4. So del R plus del T is equals to 0. So R L divided by A E plus alpha delta T B L divided by 4 is equals to 0. So that will give us R L divided by A E is equals to minus alpha delta T B L divided by 4. R by A will be sigma, that will be is equals to E alpha delta T B by 4 minus psi. See, we assumed R as tensile. Tensile is positive, right? But we got negative here. This signifies the stress is compressive. Okay, this signifies sigma C. Compressive stress is given by minus E alpha delta TB by 4. Means it is equals to 1 by 4 into a rod fixed at both ends, length L, E comma A, and change in temperature is delta TB. That 1 by 4 times of this, because this will give you minus E alpha delta TB, right? Right. So this is the question for today. With this, we end for today. In next lecture, we are going to solve one more problem on thermal stress. Until then, take care. Bye bye from 9pointer.